Hi everyone, and welcome to our presentation of the conversational chatbots Capstone project. Here's a little bit about our team. Our client for this project is the UMass President's Office, which includes Sean Skelly, Jared Jacob, Chris Matera, Nick Sardinelli, and Christina England. Thank you all. I'm joined today by Scrum Master Brandon Carvalho, developers Hadi Termos and Philip Olabayo, as well as myself, Luke Klegreafe. And additionally, our coordinators for this project, Dr. Carvalho and Nathan Block. Thank you. Next, for a sort of high-level overview of what we were tasked to do for this project. Essentially, we were to create a modular accessory to a pre-existing Slack bot named Dewey. Now, Dewey was created by the UMass P team and is used internally in Slack to perform certain employee commands, such as querying a knowledge base, creating HR, IT cases, and then searching the status of those cases. Now, the issue with that software is that it's kind of difficult to leverage outside of Slack, so if they wanted to use this cool technology on a website or via email, they have to kind of teach those people how to use slash commands, and it's not really intuitive. So we are tasked with making this entire process conversational. So on the left, you can see kind of what someone will be prompted with when they do slash create a case. So they'll have to go in there, type that slash command first, then fill out all the requirements for that case. Essentially, what we're to do is make this entire process seamless. So as you can see on the right, Dewey might prompt you, hi, how can I help you? And you can say, I'd like to create a case. From there, Dewey will understand what your sentence means, slash create a case, and will redirect you to what needs to be done. On to the features for this project. The three main features for this are the intent recognition, which is taking a sentence and classifying it under a certain intent, the API, which allows for this entire thing to be modular, and the reactive front end, which we'll go into a little bit later. Specifically for those front end features, they ended up being numerous. Specifically, we worked on a UI debugger, a manual intent handler, the ability to bulk train the model for additional input, and a database editor built into the front end, as well as authentication services, which Brandon will discuss in depth later. Now, why did we choose these features? So the prioritized features, kind of the core of the project, are again that natural language processing, which is a real requirement, really the only big requirement, as well as the API and server, which is also very important for us. And additionally, we wanted all of this to be working in Slack as a baseline, but it's also able to be leveraged elsewhere as our client sees fit. As for the additional features, a lot of these were kind of created as we were in development. We thought that there are these things that we can do, and they will kind of create a more complete experience for our client, so we decided to pursue them. Specifically the UI debugger and the manual intent handler, which just allows for more robust training. Next, we wanted to talk about how all of these components are really talking to each other, specifically at runtime. So this diagram you can see is what happens at server start. Initially, the API will make a request to the database, and it's going to fetch all of that training data. Once it gets all of that data in a JSON object, it'll talk to the natural language processing unit and have all that data trained and saved as a model. Then the NLP can prepare for a new request. And this is what happens once the model is completely trained, and now we're ready to receive input from the user. As you can see, we're using Slack for this, but it can be leveraged elsewhere since this is built on a REST API. The user can make a request to the API, and the API will talk directly to the NLP, in which it'll say, could you please classify this sentence as an intent? The NLP, now having a trained model, can classify that intent, send that back to the API as a JSON object. From there, the API will talk to the database, fill out all the required fields in the database, and it can send all that back to the end user. Also to note, we have the UI debugger and the manual handling UI here. The UI debugger kind of acts locally with the NLP, in which it's not actually editing the database or adding any new data, but it's just for our client to debug and see how the backend is actually working. And then the manual handling UI allows for the handling of unprocessed intents. So if you pass in a message and our model doesn't really understand what you're trying to say, you can handle that manually, as well as editing the training data. Next, I'd like to pass it off to Brandon, who's going to talk more about the front-end features.
Hi everyone, my name is Brandon. I'll be going over the front end of this project. So for a framework, we decided to use React simply for the fact that React allows you to create components which can easily be reused through multiple pages of our project. So like those pages are UI debugger, which gives the developer a more in-depth view of our actual NLP. So when they type in one of their sentences, it'll run it through our NLP and it'll bring back all the data of how it rated that sentence to other intents. So if for some reason the client is not getting the correct intent that they think they should be getting, they can see how well it's classifying it to the intent they expect to the one that they're actually that it's actually giving them. We also have our manual intent handler. Since this is a machine learning project, it's important to have a lot of training data. So our manual intent handler allows the training data to grow. So if an intent or if a sentence is passed in where our NLP isn't able to detect what intent that is pretty confidently, it'll send it over to the manual intent handler for our client to manually go in and choose what intent that is and send that to the training data so that they can continue to learn. We also have our bulk training. This is so if the client, say, wants to create a new intent and instead of, say, going to the manual intent handler and putting in a ton of messages and classifying that way, they can just send in a JSON with the intent and all the patterns or sentences that that intent should handle. We also have a database editor. This was a recent requirement as we switched our NoSQL database over from MongoDB's Atlas over to Heroku's Object Rocket, and there was no sort of interface with Object Rocket, so we created one that you could easily see what training data was in the database, and be able to remove data manually. As you can see towards the bottom, that is one of our components for our manual handler. So pretty much it just queries the database, gets all the manual intent or all the intent sentences that need to be manually handled, and it attaches a filter box to it and then just a save button. So next to our API was built on Express.js, which is a back-end framework. So it was very important for our client to be able to move this project to another modality they saw fit. So currently it lives on Slack, but if they wanted to move it to a desktop application or another website, email service, it was important for them to be able to just connect to that NLP and bring over all that functionality. So everything that you'll see in our React demo is built on those API endpoints, so anything on there can easily be ported over to another application. Next is our authentication, which is important for our clients since it is a lot of data and it's not exactly sensitive, but you don't want someone to mess with the data. It was important for it to be protected. So our project is protected on two ends, on the API side with an API key, and then on the front end side with just your traditional email and password login. So the email password login protects pages on our front end, mainly the manual intent handler, because you don't want anyone who lands onto the website just to be able to just classify sentences without you knowing, and then our training data page, just so that no one can just go in and start deleting data. And then, so for this we use the service provider's Auth0, which allows you to create like client secrets and allows you to create the login box that you can see towards the right. Next, I'll pass it off again to Luke.
Hi. So next we'd like to detail our actual approach to the backend and the actual natural language processing aspect of this. So this was all coded in Tensorflow Js. And so essentially what we do to get this model is format all the training data into a JSON object. Then we're going to train the model based on those set of sentences. We save that model, and then we're ready to pass through user input and predict an intent. On the right here, you can see kind of an example of what it looks like when we're passing through data. So first, let's say we pass through a sentence to training, create a case. Now, our model doesn't really understand words, it understands vectors and numbers. So we're going to identify each one of those sentences as a unique token. So we can see create a case, 1, 2, 3. We move on to the next sentence. Let's say the sentence is search a case. Now, a case has already been identified in certain tokens. So those tokens will remain the same, 2 and 3. But search is a new word, so we'll have to add a new token to that. We go through that for the entire database, and that's how we distinguish words from one another. Then, once we have all of those aspects tokenized for our user input, we send all of those through to our natural language processing model. And what we're using is a single dense layer. And so that essentially outputs an array of n-class predictions, n being the amount of total intents that are possible to classify. So for now, our client has 3 intents that we're looking at, which is the case create, case status, and ask codeo. Next, onto our data set. And as Brennan mentioned, we've moved this over from MongoDB to Object Rocket, but the functionality is still the same. So in the top right, you can see what it looks like as a JSON object for our training data. Each object in the training data collection has a unique ID, a tag, which is the intent, and then a list of patterns. The patterns are what we're training the model based off of. So we're saying, I want to create a case is associated with case create intent. as well as responses, which are kind of just flavor text that GUI will respond to you when the intent is classified. And this is an abbreviated training data set, as we couldn't feasibly fit all the patterns, as this model requires a lot of input. In the bottom right, you can see what happens when a user makes a request. So initially, an object is created in the collection with a unique ID and filled out the message as well as the date. The rest is left blank until our natural language processing unit is able to classify them, we'll fill those out, and eventually return the entire object to our end user, and they can act upon that. So, for Tensorflow Js, we're chiefly working with two main functions that we've created. The first of those is being the train model function. The train model function essentially encodes all of our training data one by one, as I mentioned, those tokenizing. And we're creating a single dense layer TensorFlow model as I discussed. For this, we're using the atom optimizer, which is kind of a standard de facto in the machine learning community. And essentially that deals with the learning rate speed, so how fast is our model trying to iterate over itself and learn. Next, we're compiling the model using categorical cross-entropy, and this essentially means that we're trying to decipher one answer out of many. We want it to be as accurate as possible, and it's not really multiple intents, it's to be one intent. Next, we're shuffling and fitting that entire data set, and we decided that 200 epochs is what we decided is kind of best for our training data as is, but the client can edit that as they see fit with more training data. The right table you can see is kind of what we're trying to accomplish here. By the end of the last epoch that was run, we're trying to get training accuracy and validation accuracy to as close to 1 as possible, 100% accurate. And the epochs in this case is just how many times it's going to iterate over itself over every single data point. And our last function for this is the predict intent function, which actually works the magic, so to say. So when we're predicting intent, we need to load the trained model, since we've saved it, and we're going to encode the user input, just as we had done with the training data. And essentially what's happening in the tf model.predict function is that we're taking those encoded tokens from the user input and comparing them to what we have in the database. And that's how our model intelligently can make a prediction as to what the sentence is. We're checking if the accuracies are greater than a certain threshold. In this case, we're working with 60%. So if any intent is classified as greater than 60% accurate, we'll say that's the official intent. And we're matching those accuracies to a classes array that we have at the bottom. What you can see is kind of an output where it's classified as case status, and then outputs an array of predictions. So it said the first index was 9% accurate about, the second is 82, and the last one is 88% accurate. Next, pass it off to Brandon to talk about the tools.
So for tools for development, we use VS Code to host our repository for documentation, for keeping track of tasks. We use Atlassian suite of tools. For client communication, we use Slack, and for communication among our team, we use Discord. To test our API endpoints, we use Postman, and we use Heroku to host our project. And then for the technologies, many of these which we have talked about, we use JavaScript, HTML, CSS, with React for our front end, with Bootstrap for styling. Express was the framework for our back end. TensorFlow Js for our NLP, and Node.js, which is the runtime environment for all of those. And then next, we're going to go to our demo. Sorry, guys. So,
Just one moment, folks, sorry.
sorry about that, guys. So Hadi is going to go into React. So this is okay. So currently in React, this is the channel where Dewey lives. So to start off, we're just going to doing, we're just going to say hello. He's going to recognize this pattern as a greeting intent, and he's going to greet us back. So say now if I want to create a case, I have an issue, so I'm just going to say I would like to create a case. This is going to get sent into our NLP, and Dewey is going to recognize it as a case create intent, which is correct, and he's going to offer you what type of case you'd like to create. From there, you would enter in like additional information that you need for your case. So next, we'll say we have a ton of cases already, and we just want to see if our case has been getting worked on. We'll ask Dewey to check the status of our case, and so that's going to get sent in. And so he recognizes that as a case status intent, and he's going to ask you what type of case, if you want to see all the ones that are attached to your name, or if you want to see the ones that by a certain case number. So next, say we have a Dropbox issue, we just want to see how to close a file request. This is a typical Ask Olabayo case for the UMass PT. So this specifically is going to ping the UMass P's knowledge base for any relevant files. And as you can see, that towards the bottom, he sends you the link of the actual article that he found in UMass P's knowledge base. If he doesn't find it, he'll offer to create a case for you, as you can see towards the bottom. So next, we'll just give it a random intent. This is just to show how our manual intent handler works, so that way we can grow training data. So say we just say, welcome to CIS Day. It's not going to recognize that. Oh, okay, maybe it did from our training. You can say welcome. Well, okay. So next, we'll just move it on. You have to do that too, but next we'll just go on to our front end. Just go, front end. Okay, so our UI debug page, so this is where they can get more information on how it classifies intent patterns. So say if we said I would like to create a case, that was one that we used before, and we send that in. So you can see it's just going to ping the actual database, and shortly you see that the intent that it gives it was case create with an accuracy score of 99.84%. And then it also gives you the other classifications of what other cases it could have been. So you can see case status, it thought it could have been, but it was only 0.14%, so obviously it didn't classify it as that. So the next page we're going to go on to is our manual handler. So manual handling is blocked by an auth page, so we'll log in here and then it'll allow us to go. So currently we just have a random sentence that was passed in, like what is the meaning of life? So you can go to select an intent. This list is all the already trained intents that we have, but you can add another one just by typing in something that's not recognized. So just say we want to do it as an Ask Olabayo. We'll save it, and it's going to send that over to training data. So next we'll go over to training data. And this is all our training data. You can filter it by the intent or by all of them. So say if we want to go back to that Ask Olabayo, and we scroll all the way down, you're going to see what is the meaning of life over there, and then you can delete any training data if, say, you made a mistake on the manual intent handler or in your bulk JSON file that you sent in. And yeah, that's it for the presentation. Any questions?
Hey guys, how do you guys handle typos? Do you have anything in place for typos and how do you guys handle that? Or is it just you have to write everything properly? Because I guess sometimes, most of the time we'll have a mistake in their entry. So you guys have anything for handling that?
So no. In our previous model that we were working with, now we're doing this in Tensorflow Js, but in previous models we had some kind of typo handling where it would intelligently understand what you're working with. However, currently there's no real typo kind of correction, so if you were to make a typo, it would classify that as a new token, and it wouldn't necessarily compare that correctly to the training data. However, with a shorter sentence, that would be a problem, but with a longer sentence, there are more tokens to kind of compare to the training data, if that makes sense.
guys, great project. My question is just, obviously, the training of your model occurs when you have the server start. Do you have an idea of what that sort of timeline would be for training time? And then also like a schedule of how long you would have the server down. So would this be something that you would take the server offline every week, every month or so?
Great question. This mic is on. Hi. So great question. The total training time has actually been greatly decreased by the use of TensorFlow Node, which is specific to Node.js. So we're really looking at less than a minute for training time, and this increases exponentially with more training data. So this would be ported somewhere else and really used to its fullest potential. Yeah, the training time would really increase. However, what we do is we save the model and we kind of cache it, so that way while the model is being trained, we're able to access it as if new request is made. That makes sense.
Thank you, guys.
Hello guys, cool presentation. I just wanted to ask is there a reason why you chose TensorFlow, that library versus another library? And also, what struggles did you have learning about TensorFlow if you hadn't already used it?
Yeah, so originally, back in probably about October, we were working with a node-specific library for intent classification. It was Node NLP. That got us pretty good classifications, but the issue with it was that it wasn't really modular, and we couldn't really, go and fine-tune things. That's what we really wanted for our client to be able to do. So TensorFlow is really the answer. Flash forward to January, we started using TensorFlow in Python, and that's when the real struggles occurred. Is kind of getting all of this down to a reasonable time. If you're working with machine learning in something like a standalone program, it can take 5, 10 minutes or hours. Really, it just depends on what you need. For a chatbot, however, we need to be really responsive and fast. So the real issue was kind of trying to clean up all the mess in TensorFlow and making sure everything's running really smoothly and getting it optimized so to say.
So, why did you choose TensorFlow Js over just Python TensorFlow? And were there any challenges going from Python TensorFlow to TensorFlow JS?
Absolutely. So like I mentioned, in January we were using TensorFlow and Python, and specifically we were using a BERT model, and a BERT model essentially looks at a sentence and it reads it all at once, so to say, instead of reading it token by token, and it's really, really intelligent. However, kind of the same issue, it was really time complex, and we were looking at like many, many minutes to train, and then the response time was really the issue, which it would take upwards of a minute to respond to the chatbot, and that's just really a no-go for something that's really instantaneous. Moving over to TensorFlow Js, things were just generally a lot faster, but the issue with that is that the documentation for TensorFlow Js was a little bit less. Things are more documented in Python, so kind of translating that was an issue. And then there were a lot of aspects where kind of made me feel that TensorFlow Js is almost a light version of Python, so we're limited in some capabilities.
Cool, yeah, that's it, thank you.
Any more questions?
So, is the system able to recognize possible synonyms of the tokens you're looking at? So, like, instead, if I put in, I want to start a case instead of create, or if I want to look up a case, and if not, how would you be able to kind of implement that to, make it more efficient, I guess?
Yeah, great question. Synonym detection is something that we were looking at back in probably about November, and we had made some tasks for that. However, ultimately what we decided is that in order to detect synonyms, we would just make more robust training data. So in our training data, we have create a case, start a case, X, Y, and Z, search a case, check the status of the case, all of those kind of synonyms we're trying to encapsulate. But as is, there's no innate synonym detection. It's really just based on the training data and making sure that's robust enough.
Great, thank you.
Any more questions?
Hi, I work for Untitled. I worked at Node Division for 37 years. As a project manager or project lead like you are, I realize that there's a lot of people behind you that do a lot very important work. So I'd like to see if the two gentlemen on the end could introduce themselves and let us know in a sentence or so or two on what their input was to the project.
Hello everyone, I'm Hadi, so I mainly work on the front end of the project with Brandon. So
hello everyone, my name is Philip. Initially I was actually working on the first version of the NLP. However, when we were transitioning into the React, I moved to the backend and I worked with Hadi and Brandon on the API. So yeah.
Okay, thank you.
Any more questions? Okay, let's play again. Going once. Are you sure? Going twice. All right, Luke and Dean, thank you.